the speaker for today's session. Share the screen.
Good evening, everyone. It gives me an immense pleasure to welcome you all to Day 4 of Atal Faculty Development Program on exploring AI using IBM Watson and Google Colab, organized by the Department of Computer Science and Engineering, Gurukul Kangri, deemed to be University, Haridwar. Today, we are honored to have Dr. Shelly Sachdeva as our esteemed speaker. Dr. Sachdev is an associate professor in Department of Computer Science and Engineering at National Institute of Technology, Delhi. She earned her PhD from University of Aizu, Japan in 2012. She has an extensive academic and research background with expertise in databases, health informatics, big data, and analytics. Over the year, she has made significant contribution to the academic community through numerous publications in journals, book chapters, and conference proceedings. Additionally, she is a senior member of IEEE and an active member of ACM, reflecting her commitment to advancing research and technology. In today's session, Dr. Sachdev will be sharing her insights on Google Colab for AI applications. We look forward to an engaging and insightful session with Dr. Sachdev. Welcome, ma'am.
Thank you so much.
Thank you for joining, ma'am. Over to you.
Thank you, ma'am.
Thank you so much. So should I start?
Yeah, ma'am. It is all to you.
Okay. So very good evening and welcome to all the participants. And thank you so much to Professor Mayank and Dr. Suyash for organizing this AICT sponsored Atal FDP and giving me this particular opportunity to speak out on something related to Google Colab and artificial intelligence. So the precise topic, as already has been informed to you, is using Google Colab for AI applications. So what I'll be talking in today's talk is I'll be first of all talking about the basics of what the terminologies are there in my title itself. After introducing the basic terminologies and theory, I'll like to demonstrate a corresponding session related to the Google Colab related to two particular things. The first thing I'll be demonstrating will be something related to an AI application, and the second one I'll be talking about the CPU, GPU, and TPU comparisons for running an application onto the Google Colab. So with these two demonstrations and moving on to the concepts that are related around the talk, I'll start my talk as of now. I'll share my screen. I hope I'm on to my first slide, and my first slide is visible to the participants. My screen is visible. Is my screen visible? Should I continue?
Yes, ma'am.
Okay,
yes,
okay.
visible.
Okay, thank you so much. So I'll first give you an introduction of the Google Colab. I'll talk about what is an artificial intelligence. Then I'll introduce you with this data science. I'll talk about the data analytics and the difference of the data science and the data analytics. I'll talk about the basic architecture and throw some light upon the CPU, GPU, and TPU. And finally, I'll present two demonstrations, one around the artificial intelligence and Google Colab, and another around the GPU, CPU, and TPU comparison for that particular application. So according to NIST's formal definition, I'll start with AAS. So what does this AAS terminology stands for? As a cloud service. So it was predominantly popular during the era the cloud came into existence, and we had a journey where we started with the software as a service, further moved on with platform as a service, then infrastructure as a service, then data management as a service, and finally now we even have artificial intelligence as a service. So this AAS is a cloud service, right? So before moving on, why I further introduce this AAS? Because the Google Colab that I'll be talking about is based on this AAS, right, as a service, right? So recently the examples for artificial intelligence as a service are IBM Cloud Pak and Vertex AI by Google Cloud, especially for ML. Now, this is what the formal definition of Google Colab is from their official documentation. So from the official documentation, the Google Colab says it's a hosted Jupyter Notebook service. So it's a service, that is why I introduced the term as a service, that requires no setup to use and provides free access to the computing resources like GPUs, TPUs, and CPUs. So it's not that it provides free access to all the computing power. It charges us beyond a certain limit. It usually charges us, but basically if we have to do some basic computation and we have to learn how to work into a Colab, it gives ample amount of computing resources to us. So Colab is basically suited to machine learning and data science and education. So the applications that are revolving around the artificial intelligence, the Colab suits for that particular purpose. Now, before moving on to and introducing you with what is an artificial intelligence, so there were two particular terminologies into my talk. The first terminology was talking about the Google Colab. The second terminology was talking about artificial intelligence. So before I talk about artificial intelligence, let me introduce with the term and the differences between what is a data. So here an example is being cited, and the example says that 160 by 110. So into the layman terms, if I simply talk about this one, without stating anything, somebody may be able to understand, somebody may not be able to understand in what context I'm talking about, right? So when I talk about 160 by 110 mm per Hg, it means that I'm talking about a blood pressure. So as soon as I append a unit mm per Hg to 160 by 110, it appends a meaning to that, and that particular data is being converted and we have a meaning being appended to it, is referred to as information. Now, since all of us are usually aware of that the normal range of the blood pressure is 180 by 120 mm per Hg, right? So since the value currently with me is 160 by 110, which means that the 80 has crossed to 160. So the level of the BP is high. So 80 by 120, if compared to 160 by 110, it means that the blood pressure has increased from the normal level of 80 to the level of 160, although the lower one is 120, which has been reduced to 110. So normally in the context, it is understood that the level or the value of the blood pressure is beyond the normal blood pressure. So the patient, whosoever is having this particular value, is having a high blood pressure. Now, what further is that what should be done, right? So the patient X needs to be investigated for this particular high blood pressure, which is usually referred to as hypertension. So the patient X needs to refer to the cardiologist, which is referred to as wisdom. So this is just the transformation of a journey from data to information, appending a meaning, then extracting the knowledge out of it, and finally extracting the wisdom for that particular system. So now, since the term data, information, knowledge, and wisdom are clear to us, I'll talk about AI, right? So the artificial intelligence is a broad and interdisciplinary field that tries to enable computers to have human intelligence to solve complex tasks, right? So complex task, and what it says is that you want the system to behave as if the human behaves into the normal things. For example, the next slide will give you an illustration of how we mimic the machines to behave like humans. So it says that the data is the concept to describe a collection of values that convey the information, and data is in that particular in AI terms, the data is used to train machine learning models or serve as the model input to make the further predictions. So now the data can appear into various particular formats. We may have a tabular data, we may have an image data, we may have a text, audio, or a video data. And we want to plug and play with all these kinds of data, and we want the machine to correspondingly respond for the various formats of the data. Now, there was also a term that is recently being introduced, and the term was the data-centric AI, right? So what the data-centric AI says, that framework to develop and iterate and maintain data for the AI systems was data-centric AI. So what it basically involves, so it basically involves the tasks and methods for building effective training data, designing proper inference from that particular data, and maintaining that particular data is the data-centric AI. So this is the example that I was talking about. So for example, if I consider the bigger umbrella as artificial intelligence, it says that these are the machines, and these machines will mimic like the human. On what the human can do, human can learn, human can think, and human can act. So whatsoever we have programmed inside that particular machine will behave and will try to mimic like human. That is the terminology artificial intelligence. Now, under that comes the machine learning. So where the machine learning detects what action should be taken when an obstacle occurs. For example, this particular car is driving and an obstacle is there. So the machine learning would detect that when this particular obstacle is there, should the car stop, or should the car further be acting on seeing this particular what action should be taken. So this is what the machine learning do. And then further, it can be of type of supervised learning or a non-supervised learning, right? It can be a semi-supervised learning, or further it can be a reinforcement learning. Then under that, our brain has usually neurons, right? So considering that particular neurons, there is one thing, the terminology that was being introduced called as a neural network, right? So under the machine learning, a smaller domain of it is usually that we usually used to do for the images most of the times. So that is a deep learning. So it has more than, for example, this is the input, this is the output. So we have a neural network from their input output, and there's a layer called as a hidden, right? So now this hidden layer can have many connections with the input, many connections with the output. For example, these cells are neurons, and we can have many hidden layers, right? So then it's the deep learning. So the data mining, now there is one term which has an intersection with all these terminologies, that is called as the data mining. So data mining does not deal with the obstacles into the real time. It needs to wait for an analysis to be initiated by the human, then correspondingly what was happening into a machine learning. But it has an intersection with the corresponding thing. So that is what the artificial intelligence is. Now, the terminology called as a data science. So the data science, as per, there was an ASIM computing survey paper from where I picked up this particular definition, which says that the definition was being defined by the National Consortium for Data Science in 2013. And it states that it's a systematic study of digital data using scientific techniques of observation, theory development, systematic analysis, hypothesis testing, and rigorous validation. Now, what this particular terminology or a definition says, it says that data science is an interdisciplinary thing where the mathematicians, statisticians, computer scientists, the business domain specialist can work in collaboration. So it's not that data science was not existing earlier. It's just a terminology that was being coined into 2013. So into the NASA, into the ISRO, the earlier statisticians and mathematicians were working on these particular set of problems. So it says it's just an accumulation of all these particular domains. So I cannot say that if I'm a computer scientist, I am a good data scientist. A mathematician can also be a data scientist. So that is why it is referred to as that scientific techniques of observation, theory development, systematic analysis, hypotheses are being tested, and a rigorous validation is being done. So that is what is being referred to as a data science. I'll also talk about my personal view of what is the distinction between an AI and what is the distinction between a data science, and further the data analysis and data analytics. So now this is as per the paper was narrating that these are the key purpose of the data science. First one was to create the knowledge about the properties of the large and the dynamic data sets. Now, what do he mean to say here is that we are constantly recording and maintaining the data sets. For example, I just give you an example of a dynamic data set and a very large data set. I'm traveling from the Google Maps, and I'm using the Google Map, and I have a source and I have a destination, right? So I'm a single user independently thinking I'm the independent one using the Google Maps. So whenever I change my particular location, my time is usually decreased, and then my location is updated and it says that these many minutes to your destination. Then further I move a little bit ahead, it further changes. Then further I move, it later changes, and finally until and unless I reach my destination. So can you imagine the number of the readings that are being recorded for a single user? Me as a single user traveling from one source one to destination one. So there are an n number of other people or the customers also that are using Google Maps. So they are also generating data, right? And the Google Maps is correspondingly penning them down. So these are large as well as these are dynamic data sets. So then developing
Kindly unmute yourself. Someone else. Swish, we can withdraw the permission to mute.
Then the next one is developing methods to share, manage, and analyze the digital data. So once we had the particular dynamic and large data set with us, then we develop methods how to share, how to manage, and how to analyze the digital data. And finally, we talk into the data science for optimizing the data processes for factors such as latency, cost, and accuracy. So these are the basic key purposes of the data science. And what's the key purpose of the artificial intelligence? So if I compare this particular key purpose of the data science with the artificial intelligence, you'll be able to figure it out. Okay, there are some things that are quite common in between the two, but there is something that differentiates the artificial intelligence from the data science. So this is actually the job of a data scientist. So for example, just consider that we have all of us might have played into our childhood the Lego blocks. So these may be considered as the Lego blocks, right? So these were simply considered as the raw data. So what we usually do, so we usually used to sort them. Okay, red को हम अलग कर लेते थे, white को हम अलग कर लेते थे, yellow को we usually differentiated, and we usually differentiate the green ones also. Then we usually try to arrange them, right? Black into a single row, then yellow, then this one. And then we present them visually. Okay, how many blocks are we having for blue one? How many blocks are we having for red one? How many blocks I'm having for... So I just see the distribution of the data, right? So I'm trying to categorize, okay, I can use these particular color for this many number of times. I can use this particular color, and then I can explain it with a story. So since I had recognized that the red one were the most one, so I can use, and then I can analyze, okay, this is the most one which I can use for creating this particular house or this thing. Then I have the yellow ones, then white ones, and then the blue ones, right? So this is explained with a story. So this is what the purpose of the data scientist is. So now, please try to understand this, because while I'll be demonstrating into a Google Colab, I'll be demonstrating this particular role of where to start with and then where to reach with, right? So the first thing is understand the problem and the domain. The first thing is, right? So understand the problem and the domain is that what I'm trying to do is I'm just trying to understand what is the problem. For example, I'm working onto an healthcare domain, right? I asked Safdarjung Hospital to release the data, and I said, okay, I want to analyze this particular data. But the Safdarjung didn't collected the data as per what I want to do an analysis. The Safdarjung Hospital simply noted the data. Okay, what was the name of the patient, at what particular date or time he wants to have it. For example, an appointment data was there. So we generally used to have an app, and from the app, we usually used to take an appointment for visiting the Safdarjung Hospital. So we just mentioned which particular department we want to visit. If in case we don't know, we generally mention it, but and it generates a time and the other things for us. And when once we'll go there, we tell them this particular thing, they'll see the data that they recorded, and then they further add some things that this person should visit this particular department and this particular doctor, and whatsoever the doctor gives the prescription, and this is the way they collected the data. But I wanted to analyze, for example, the data from, for example, how many of the patients were suffering from dengue during this particular period. So they were not collecting the data for this particular purpose. Their aim was to give an appointment, send to the corresponding doctor, right? So they just collected. But I am quite well aware of the domain, and I work into, for example, a health area. So I know, okay, this might be the terminology or the name of the department that will be dealing with the dengue, right? So maybe a general physician or some certain this thing, or nephrology department or a gynecology or whatsoever the domain is. I want to understand the problem, and then I understand that domain. Then the data is being collected, the data was collected. Then finally, I need to clean or process the data, because the person who is entering the data may or may not be a doctor, or may not be a skilled into that particular domain, right? Or he forgot to enter the particular entry. For example, the blood pressure entry, he forgot to mention for one particular patient. He was in hurry, and maybe a typo or something as an error. So systolic value was missed, and the diastolic pressure related to a blood pressure was being entered. Okay, so that particular value is missing. Now another example is the person had to enter one, numeric one. And despite of writing a numeric one, the person entered ONE one, right? So these kind of things, and sometimes while entering, right, I was entering 80. And by default, the 000 was pressed, and I was on to my next entry, and it was 8,000. But 8,000 can never be the value of the blood pressure, right? So all of us knew this thing, that no, the blood pressure cannot be this one. All the values are between the range of somewhere 70 to 100, and how can this be 8,000, right? So that is why we need to clean and process the data, right? So after the cleaning and processing the data, we need to analyze the data, right? So analyzing is something where I had, okay, what is the distribution, what is the mean, what is the mode, and what is the variance, right? So I need to analyze the data for the particular purpose before sending it further for the purpose of data analytics or prediction. So right, so that is where I did the explore data and feature engineering, and finally I predicted the whatever I want to predict from that particular data set. Okay, so this is what usually a data scientist is doing is. So these are some of the tools of the data science. For example, R, Apache Spark, BigML, MATLAB, Tableau, Matplotlib, and Jupyter. So these are the tools of the data science, and what we'll be using into a Google Colab, we'll be using the Jupyter notebook in order to analyze this particular scenario. I'll be showing you one particular data set where I'll be showing you a demonstration with Jupyter notebook for the corresponding task. So this is what I picked up from an Amazon site, where they demonstrated that, okay, what in common usually the data science is with the artificial intelligence. So it says that what is it, right? It says, first of all, it is the use of statistical algorithmic modeling to obtain the insights from the data, that is the data science. And the artificial intelligence is we usually want to build the systems, right? For example, if I tell you, okay, this is a robotic production line, and this requires a very small human intervention, and then the industry totally works upon this particular robotic production lines. And another example is a chatbot. So they will try to answer you as if some particular human is answering at the back end, right? For example, like DFC has an chatbot named as an EVA, and that particular EVA usually used to gives you the answer as if a human usually used to give, right? But into the data science, it usually answers a question from a set of data. For example, the sales demand forecasting, what can be there, the fraud detection, right? So this, from the applications, you might be able to differentiate between the data science and the artificial intelligence. The methods that are basically used for the data science are linear regression, so logistic regression, anomaly detection, binary classification, k-means clustering through the supervised and the unsupervised learning techniques are usually used, and principal component analysis for the feature selection, and many more. And while I'm talking about an artificial intelligence, we also use the method of facial recognition, natural language processing, reinforcement learning, knowledge graphs, artificial generative AI these days now we are using. So that's what we use for the artificial intelligence. Now, what is the scope for the data sciences? We have a predefined questions that can be answered from the data, and into the artificial intelligence, we have a broad and difficult to define, and it is usually the task based. So we use a different range of tools in order to capture, clean, model, analyze, and report the data. Now it typically relies on complex, pre-built, productized components, right? So it's task dependent. So depending upon whether I want to create a chatbot or I want to have a robotic production line, the artificial intelligence, the human will behave differently into different scenarios, right? So since as the human will behave different into different scenarios, the corresponding intelligence of the human is being required. So correspondingly, if I'm doing or creating a chatbot, it will be correspondingly responding to that. And if I'm having or using it for a different task, then correspondingly it will be behaving like a human as a different one. So now this is what the understanding is. But the Amazon, the last slide which I showed where the Amazon compares between the data science and AI, this says that it's not that one is predominantly dominating the other or other one is predominantly dominating the others. But while I discussed with some of the scholars and some of the students, they gave me this particular terminology which I had drawn at this particular place, right? So they told that this is a umbrella of a data science, and then there is we use the artificial intelligence, and where we had the corresponding subsets as this one, and where we have a data mining as a domain, and we usually do the data analysis where we have the mean, median, mode, variance, standard deviation, and data analytics also, right? So how do I differentiate and say, okay, some are usually getting a master's in data science and some are usually getting a master's in data analytics? Okay, so is getting a degree into a data science is the same as getting a degree into an data analytics, or is getting a degree into a artificial intelligence specialization is the same as the data science? No, they are not specifically the same. There is a little bit variation. So the keystone of the data analytics is the data science, right? So the keys, so what it says is that what usually data analytics is doing. So this data analytics is understanding the data, extracting the knowledge, and providing actionable insights, and that usually is helping in a decision making. So the data analytics is usually considered as the keystone of the data science, right? So now there are various types of the data science where we usually have a prescriptive analysis. Then we start with the descriptive analysis, move on to the diagnostic analysis, then predictive analysis. So we just give a description into the descriptive analytics stating that, okay, this is the description that this has happened, right? Into the diagnostic analysis, we usually used to give a reason like, okay, why, what has happened, right? And why it has happened. So there is generally usually whenever there is an incident or something, right? So what usually is the first is simply a reporting stating that this thing has happened, right? Now after that it comes as an investigation. Okay, what has happened in actually, what has happened, why it has happened, right? Then further, what particular remedial action can be taken, can it be taken, how it happened is also to be analyzed, right? So we need to have an answer of what has happened, how it has happened, right? And why it has happened, right? And what can be further actions in order to get a scenario where we can make ourselves, or we can have a decision making kind of a ability from that particular system. So that is where we distinguish between the descriptive analytics, diagnostic, predictive, prescriptive, and proactive analytics. Now, this is what it usually says, that data science is equal to statistics plus informatics. So this is just a conclusion of what the data science, data analysis, and data analytics is. So statistics plus informatics plus computing plus communication sociology plus environment plus management, data and thinking is referred to as data science, right? And data analysis is, we usually use the classical mathematical and the logical things like machine learning, neural network, and predictive modeling. That is used into data analytics. So we usually use the classical statistical mathematics and the logistic theories to obtain the useful information. Now into the data analytics, we use the theories, technologies, tools, and processes that enable an in-depth understanding and will provide an actionable insight. So the main core is to convert the data, extract the knowledge, and finally extract a wisdom out of it. So that is what the data analytics is doing, right? So data analysis may be doing this particular thing, that while conversion from a data to an information, right, is the part of the data analysis, but from data to information, further to correspondingly move on to the knowledge and further to the wisdom is the complete pipeline of and the work of the data analytics, right? So I started with the descriptive analytics, where I usually just given the statistics that this thing has happened. Now into the, so what has happened is usually answered by the descriptive analytics. Why it is happening is answered by the diagnostic. What will happen, right? What will happen? For example, there was a stampede scenario into this particular right now Mahakumbh. So what was the first thing that was given to us as a news is that the stampede has happened, right? So only the description was being given to us, right? Why it is happening, then the further investigation was being done and they tried to figure it out. Okay, this is the reason that why it has happened, right? Then the next thing was is the next day, and the next to next day was also a major one. So what will be happening? So the precautions needs to be taken for that particular thing, but until and unless we are not knowing why it is happening, we'll not be able to further stop that particular thing. So what will happen? And finally, the predictive analytics is, what should I do, right? What should I do in order to avoid this particular scenario? So this is where we talk about the different kind of analytics. So this is the complete data analytics various phases, where we first receive the data receiving module is there. So it's says that, so this is just a figure being taken up from a research paper itself. So if you see in between the data analysis layer and the upper and the lower one, there is a persistence layer where we have a back-to-back connection, and then we have a governance layer where we have back-to-back connection. So the data receiving module will gather the data from different places, maybe the APIs, maybe through web scraping, maybe from official and on databases. And further, this particular data goes to the data pre-processing module, right? So I talked about the data pre-processing module and I said that, okay, null values will be removed, the abnormal values will be removed, the normalization of the data will be there. Finally, since the data was being gathered from different places in this particular scenario, one was from gathering from the Twitter, Facebook APIs, another was through the web scraping from different particular websites and URLs. Then another was from the different databases. Another is from a GPS or a Google Maps or something like that. So that is why a data integration module is being required. So what the terminology was there into the first one needs to be integrated with the same whatsoever the meaning was there. The data term needs to be integrated as per that. Now the data preparation module is there, where we usually have the dataset 1, dataset 2, and dataset 3, right? So depending upon how we integrated the data. Then further now comes the layer where we apply the data analytics module. So here we usually we can apply an ML algorithm, we can apply a DL, we can apply a neural network only after we see what has been gathered after cleaning and processing of my data, right? So since I analyze the data, I'm better able to decide whether I'll go for a decision tree or whether I'll go for a linear regression, or whether I should go for a further maybe a decision tree. Okay, so that particular thing is being cleared while the data analysis is being done. And sometimes there is a feedback phase as well before publishing the module. So sometimes it's not. So if my particular model is not performing well, then I've usually feedback is being provided. I again look into the various phases and then I apply the analytics, and finally then I publish the module. So before the result publishing, there may be a feedback phase as well. So this is what is generally being done. So I'll just demonstrate a case study, right, where I'll be again revisiting the same thing. I'll be understanding the problem and the domain. I'll be collecting the data, cleaning and processing, then data analysis, and then further production. So, okay. Okay. Okay, I'll be demonstrating. Just give me a minute. Why are these slides are coming? Some slides went into the hidden mode. Just let me show that, and after that, I'll show you a demo. Okay. So this case study I'll be showing to you, and then further I'll be demonstrating it through Google Colab. So simply see, this is what I said, that this is what the role of the data scientist is, and this is what for a particular case study I have a diabetes prevention case study where I simply, my goal is, what if we could predict the occurrence of diabetes and take appropriate measures beforehand to prevent it, right? So this is what the goal was, right? So the goal was to predict the occurrence of diabetes and take appropriate measures beforehand to prevent that particular scenario, right? So the step one is the data collection. So into the data collection, depending upon the medical history of the patient, right, is these particular attributes are there and the data is being collected. So NP-REG stands for the number of times pregnant, the glucose stands for the plasma glucose concentration, BP stands for blood pressure, skin stands for triceps skin fold thickness, BMI stands for the body mass index, PED stands for the diabetes pedigree function, and age stands for the age, and income stands for income, right? So the first thing is that what I got into the data set is these particular attributes, right? So while the data collection is being done, can you see that something needs to be, okay, I'll show you a sample. So this is just into form of, for example, a CSV that was being calculated. So now what the step 2 says, I want to clean and pre-processing is to be done, right? So just see the sample data. If you see NP-REG, it's a numeric one, but at this particular place, it's written ONE1, right? For glucose, you see this is blank, right? For BP, you see it's 6600. For BMI, it's blank, right? So handling null values. And then there is something called as an income, but that income is blank. Income is not having anything. Income is just blank. So does income has any relation to the diabetes prevention and this thing, right? Cannot be understood why it has been given into the data set, right? Because I told that the data set might have been calculated for something else, and we are doing an analysis for something else. So that is why you first need to clean the data and first need to prepare the data so that you should be able to find out whatsoever your particular goal is. So that is why what you will do now is you try to remove this particular income, because you don't think so that that particular attribute is going to contribute towards the diabetes prevention, and you want to change these particular values. So you'll be handling these null values and you'll be handling this one. So this is what it says, that you need to clean and you need to prepare the data analysis for the purpose of further sending it. So you have already seen, I've already shown you that the particular discrepancies are there. So the discrepancies have now been removed, and it is, for example, being replaced by one. This glucose is being replaced by this one. The blood pressure is being noted at this one. Then the BMI value that was being there. So what usually can be one of the things is you take an average of the upper and the lower one and usually fix something at maybe. But if in case of an healthcare data, you have to be very cautious in correspondingly substituting the value. So there are different methods for doing this particular thing. So you have to apply that, right? And you simply remove the income column. Now the third one is you have to analyze this particular data, and what after the analysis you have to get a fair distribution of the data, right? So for example, this is NPREG, the fair distribution and the visualization is shown. Then for glucose it's shown, then for BP it's shown, for skin it's shown, then for PED, BMI and age, the particular distribution is being shown, right? So you can use the statistical functions like mean, median, range, minimum and maximum values, where you can see the summary functions, and you can use the corresponding toolbox. So basically the Python is very good at providing us with the machine learning libraries, and it has a toolbox where it has various corresponding analytical sandbox, and you can use the various functionalities or the functions without doing a coding or writing a code. For a logistic regression, you can perform it without writing a code. For implementing a decision tree, you can simply call the function and you can use it, right? So this will be further used into the next phase, but for even for this particular kind of mean, median and range, finding out the minimum and maximum, it automatically is doing and visualizing it for you by into very easier way. So you need not have to put in much efforts, and the Python will be able to. So you might have I was seeing and going through the brochure, and I saw that you had on the second day you had a demonstration of the PyTorch, right? So considering that you are already aware of some of the machine learning libraries and you have an idea, I'll give you the demonstration. So this is the visualization. Now this is the most important step where you have to focus upon, where the Python provides you many functionalities which you can use. But until and unless you'll not see this distribution of the data that is being shown over there, you'll not be able to decide which one would be a better one, right? For example, applying a linear regression has some certain prerequisites, and applying a decision tree has some certain prerequisites. Getting it? So once you analyze the data, did the data analysis part, now particularly you can see that what kind of particular learning technique you can apply on the top of it. So it says that you can apply supervised learning technique, right? So particularly why decision tree? So the first reason for this particular data set to use the decision tree was it takes all the attributes into consideration in a single go, right? Right. So like the ones which have a linear relationship as well as those which have a non-linear relationship. So for example, the linear relationship was there between NPREG and age, and the non-linear relationship was between NPREG and PED. Right. So these were so it says that it will be considering all the relationships into a single go. The second reason was that it is a robust, and you can have different combination of attributes to make various trees, and then finally implement the one with the maximum efficiency, right? So that is why, and then correspondingly you can either have a positive or a negative thing, right? So POS means the tendency of having a diabetes is positive, and NEG stands for that the tendency of having a diabetes is negative. So considering this particular thing, this is, for example, the decision tree, and the corresponding as per the values that were being displayed over here. So this is being formed. Now you see the results of the decision tree. If you think that it is not giving a better one, you have to apply a feedback, and then you replan and rebuild the model. And then before that, yeah, you need to divide it into a training and a testing thing. So normally some of the papers says it's a 70-30 training and testing. Some of the papers says it's 80-20, right? So you just have to see and consider the cases of the overfitting and the underfitting as well. And then you have to consider for, so normally whenever I usually do an experiment along with my students, I usually do it or for a 70-30 training and testing. And once the project is executed successfully, you'll share the output for the full deployment. So now I'll stop the slides here and I'll give you a demonstration. So I'll show you a tutorial as well. Okay. So I hope you are able to read it. Okay. So this is what it says, that you first have to create a Google Colab account if in case you don't have, right? So first thing is you just have to, if you are onto a Google, right, you can create a Google Colab account. Then you'll be learning how to run a simple machine learning model using a sample data set. And the third part will be the demonstration for the performance of the model on the CPU, GPU, and TPU processes. So that's the, okay, I guess. Okay, so this is a simple thing I can show to you. So this is just the concept of the Python, that variables x is equal to 10. You simply assign a value using a variable. Then you have some certain data types, int, float, str, do, list, boolean, and all this. Then print function is there. You can print and you can print anything. Then there, this particular symbol is being used for putting up a comment. For multiple line comment, you can have this particular terminology. Then the conditional statements are being used, like if x is greater than 10, then you print x is greater than 10 or something. The else is like this one. Then else if is usually represented by ELIF, x double equal. So this particular symbol is being used for checking whether it is equal or not. Then for I in range 5, you print I is for the loops. Then while x is less than 5, print x is equal to x plus 1. This is for the while loop. So this is just the syntax for the Python. Then yeah, this is important where you should know about the little bit about the libraries that are usually used during the machine learning. So the first library is the SCI kit learn, right? The library having a numerous amount of inbuilt functions. So it's basically used for the classical machine learning algorithms like regression, classification, clustering, etc. And then you have a module of a TensorFlow. So it's basically used for the deep learning. The Keras is also used for the deep learning. The PyTorch, it's an alternative to a TensorFlow created by the Facebook, and it provides more flexibility, and it uses dynamic computation graph. Then you have NumPy and Pandas that I'll be using for the current demonstration for numerical operators, which are crucial into the ML. You will be using this for mathematical computation. Then you have Pandas for data manipulation and analysis, as you use the Pandas. Then XGBoost for gradient boosting algorithms that are highly efficient and effective for structured or tabular data. Then Matplotlib for data visualization, we will be using this particular library. And time. So since I said that I'll be showing you a demonstration related to a GPU, CPU, and TPU, so I'll be demonstrating the and using the function that is time. So this is the benefit of the Colab, that it comes usually with the pre-installation of all these particular libraries, right? And okay, now we'll start with the demonstration. So I open my this one and I'll type Google Colab. So since I'm already having an account, so it will not ask me to create an account, and this demonstration shows that I'm already having an account on the Google Colab, and it will, otherwise what you can do is you can create an account over here. So the first thing is, it says that, for example, I will cancel this one. Yeah, or otherwise from here also, you can see that my tab is new notebook. Okay, so from here I can create a new notebook. So if in case I want to create a new notebook, for example, I created a new notebook. So I've entered the session. So this is the Google Colab, that is service, right? So now it says simply start or generate with AI. I can even code by myself. For example, I simply do the first one where I simply print hello world. So this is the Jupyter notebook where I'm working on. So for example, here you can simply give the name to that particular notebook and you can have anything. Now what this notebook can have, this particular notebook can have code, this particular notebook can have comments, this particular notebook can have text, it can have images, it can have anything what you want. So working onto a single notebook, you can keep everything over here and still you'll be able to execute the code. Now the Python is the kind of a language which doesn't need a compiler, it just needs an interpreter. So it can interpret line by line. So that is also a very good thing for this particular thing. For example, through this particular button, you can run the code. For example, what is the expected output is hello world will be printed as it is while I'll be executing this particular code. So I just pressed this and look. At the bottom, what is shown is connecting to Python 3 Google Compute Engine backend, right? And it says in 0 second, it is completed, right? So hello world is being printed. I just gave a command and I tried to create my first particular program onto the Google Colab, and I just printed a hello world and it reverted me back with a printed hello world, right? So this is the first thing, how to write. And then I'll open an existing open the notebook. So these are, for example, the existing notepads that are there, right? So there are already inbuilt codes also, which you can try and run and can practice it. Otherwise, you can do these ones as well. So it totally depends upon the network speed you are having, right? So depending upon the network speed, it will give that particular thing to you. So usually whenever the network speed is very good, the Google Colab is a very good option to do that, right? So first it says that considering, I'll show you the data set that I'll be working upon. Yeah, so this is the data set that I'll be working upon. I'll give a little bit description of a data set. So this is the description. So the data set was being picked up from the Kaggle, right? And it was a red wine quality data set. But what was the purpose for doing with this particular data set was that the quality of the red wine is usually influenced by mainly physicochemical factors. So the ability to predict the quality of the red wine is usually based on significant factors. So the aim was to develop a predictive model that can estimate the quality of the red wine based on these physiochemical attributes. Right. For example, what were the particular attributes? The fixed acidity was there, the volatile acidity, citric acid, residual sugar, chlorides, free sugar dioxide, total sulfur dioxide, density, pH, and sulfates. Right. So these are the corresponding columns into the data set, and then the sample of the snippet of from there is being picked up and shown for the clearance or the. So apart from that, there are two particular more attributes. So in total, there were 12 attributes for that particular data set. Now we'll try to, since you can see that onto the Kaggle, when you can see this particular distribution of the data set was also being there, so that which particular attribute is having how much of minimum and maximum is also being displayed over at this particular place. Depending upon this, you need to clean and you need to analyze the data set. So this is my data set. I have kept this particular data set at some particular place into my system. So what I'll first of all do is I'll simply write from is an already reserved keyword, google.colab import files uploaded is equal to files.upload. So the first thing is that you are preparing the Google Colab to upload your CSV file. That is the red wine dataset that I've shown to you. Then you have imported the NumPy and Pandas library, right? And then you want to read this particular CSV. So now it says that, okay, while I'll be executing this particular, so df is a data frame. So data frame will correspondingly, this is a NumPy variable, this is a pandas, right? So pd.read CSV, wine quality.read.csv, right? df.info, आप इसकी info को display कर दें. Then if you do the sum of all the particular columns over there and just check whatsoever is there it being captured into a data frame is correspondingly having, if any particular column is having a null value or not. So this is the corresponding code for that. Once you run it, it'll say connecting to the Python 3 Google Compute backend engine. It'll prompt you to choose the files, right? So the files are not available onto at this particular place. It will tell you, okay, now you select your data set. So where you have kept your data set. So this is where I've kept the data set. I selected it, I chose it, and I opened it. So while I collected it, it says 100% done. So while it is displaying 100% done, it shows me that this is my column name, fixed acidity, volatile acidity, and then this is the non-null count, and this is the data type of those particular attributes. So this is what is being displayed, and this is def.info with the null values ka sum. So since the data set was already clean, so correspondingly it says that there is no particular discrepancies into the data set, and it says that the data set is quite clean and the null values are 0. So that is why this cleaning process was not being required. Otherwise you need to apply a Otherwise, you need to do the data pre-processing on that. Now, next is we want to now further do the next process that a data scientist usually has to do. So what we are doing is we'll apply a logistic regression on the top of it. And for that particular purpose, we are just doing one thing that we introduced one particular parameter called as a good quality. And we defined that good quality parameter is equal to 1 if the value of x is greater than equal to 8. So our quality was one of the column that was already there into our data set. And we assigned a new column called as good quality is equal to 1. Otherwise 0. If the value is greater than the 8, we kept it as a binary 1, 0, or otherwise we kept it as a binary 0 and 1. So the good quality is being added as an attribute using this particular df good quality is equal to 1 if x is greater than 8, else it is 0 for all x in df quality. So this will give the values to the column named as df good quality. Now x is equal to df dot drop quality good quality x is equal to 1, and y is equal to df good quality. Then from sklearn we'll be calling this using this particular library. We'll be calling sklearn.ensemble import extra tree classifier. So now classifern is equal to extra tree classifier, and then classifier.fit x or y. Now we'll further split the data into the training and the testing one. So after we had applied the extra tree classifier from the SCI kit-learn, we'll be dividing it into training and testing one. So we considered the test size of 0.3 and the random state is equal to 7, right? So x train, x test, y test, y train, y test is equal to train test split, and we split it into this one, and model underscore r is equal to pd dot data frame columns is equal to model and underscore. So this particular code will split it into the training and the testing one, and the further code will be for noting the particular time, right? So now this will import a library, will import the time, and we'll have start is equal to time dot time. Now we'll import the logistic regression from the SCI training data into the model and predict using the testing data. So from sklearn.linear model import logistic regression, model is equal to logistic regression, model dot fit x train, y train, and y prepared is equal to model dot predict x text. Now we started the time before we started doing the logistic regression, and we end the time at this particular place, right? So then we'll correspondingly note the time, and we'll use different particular processes to give the or elaborate this particular time. So let us try to run this code and see what is happening. Okay, so it says that the time taken for the model to run is these many number of seconds, right? And this it tells about this thing. So we did the predictive analytics and we were able to apply the logistic regression, and then we noted the time that in these many particular number of seconds we were able to get the results of the logistic regression. Now back on to my slides. So in case anyone has any question, can ask me the question. Okay, then if there are no questions, I'll give you the time at the end to further ask the questions. So further, I'll start with the next part where I'll be talking about processor, that CPU versus GPU versus TPU. I said that it gives you the Google Colab will be able to give you different processing powers, and says that okay, the current program that I was working on was working with a CPU, then I'll show you and demonstrate how to change it to a GPU and further how to change it to a TPU. Now, what is the difference between a CPU versus the GPU versus the TPU? So until and unless we know the basics of this particular thing, it becomes a little bit difficult to further get onto it. Okay, so let us try to understand what's the difference between the three. So CPU stands for the central processing unit, GPU stands for the graphics processing unit, and TPU stands for the tensor processing unit. So whenever I talk about a CPU, it's that I want as low as possible the latency, right? I want that it should. So what happens into a CPU is that usually it performs the task into a serialized way. So the main motive is to keep the latency as possible as there. Then GPU is all about the throughput optimization, allowing to push as many possible tasks through its internal at once. So usually when we are doing a parallel kind of a computation, the GPU is usually for doing a parallel kind of a computation, and it is good for whenever we are doing usually a gaming graphics is there. So the GPUs are usually known for that particular purpose. So to increase the throughput optimization, the GPU is basically being used, and GPU is usually having a parallel processor. So I just will move further. So if you see, so this was from one of the white paper from the VMware, which simply try to give a demonstration of, okay, what's there into the CPU and what's there into a GPU. So the current figure that is being shown over here shows the cores, right? So for example, here in the CPU, you are getting a thing that you are having, this are the number of the cores for the CPU. Then these are the corresponding number of cores for the GPU. So the main purpose is to have a low latency, and here the main purpose is to run the task into the parallel one and to have a throughput optimization. For example, the basic make is being done by NVIDIA and AMD are nowadays producing this GPU. So NVIDIA Tesla V100 is one of the model by the NVIDIA in 2019. They said that this particular GPU is having 80 multiprocessors clusters, and then each particular processing having 64 cores, and then in total it is having 5120 cores. So for parallel processing, they are making use of these many number of cores. So if you see the simple uh, architecture, how, but it varies from particular model to model, right? So this is in general, the recent CPU are using this particular model. It is simply demonstrating that particular thing, that the CPU is having a core 1, core 2, core 3, and core n. So for example, the current CPU is having a number of cores, and if you see, this is the L1 cache, this is L2 cache is common for all the cores, and then L3 cache is there, that is common to all the three. Then PCLE bus, system agent, memory controller, and DDR4 memory is there. Then further GDDR5 RAM is, this is for the GPU. Now, if you consider and compare the architecture of the CPU with the GPU, you can correspondingly see that, okay, this is one cluster. This is another cluster of microprocessors. This is another processor cluster, right? So these streaming multiprocessors are there, right, having different cores. This is a cluster and all of them are having L1 caches being there with the streaming multiprocessor 1 till multiprocessor n. So that process cluster 1 is having this one and having a memory controller. Then the processor cluster 2 is having this one and having a memory controller. Then processor 3 is having this particular streaming multiprocessor and having a microcontroller, and this processor cluster n is having another streaming microprocessor and the further memory controller and the memory. So if you compare this particular CPU architecture with this GPU architecture, you can see that this is the difference, right? So here the main motive was to do the parallel computation of the task, and here it was to have a low latency. So this is the basic architecture, and this is in general if you compare the CPU versus the GPU versus the TPU. So the primary function is general purpose processing like an arithmetic, logic, control, and IO operations. In GPU, the graphics rendering and for the gaming purpose, and you basically focus upon the parallel processing. In TPU, you have a more perform task of, for example, running some deep learning libraries. Also, the performance is tens of operations per second cycle. In GPU, the performance is 10 raised to power 3,000 of operations per cycle, and into the TPU, you have 1 to 8,000 operations per cycle. The data processing unit is usually can be considered as a single scalar, but I'm again and again repeating, it varies from one particular model to another model. For GPU, it is 1 into n vector processing unit, and for TPU, it is n into n matrix processing unit. So it is best suited for the general computation and operating system operations, whereas the GPU are good for gaming, image processing, and parallel computation. The machine learning and deep learning and tensor-based operations are there, and the manufacturers for the CPU are Intel, AMD, IBM, and Samsung. For GPU, it's NVIDIA and AMD, and for TPU, it's Google. So the power consumption is very high for CPU. For GPU, it's moderate to high, 80 watt to 250 watt for discrete GPUs, and for TPUs, it's lower due to the optimized matrix processing. The memory subsystem is optimized for the usually sequential execution into the CPUs as compared with the parallel processing for GPUs. Then parallelism is usually low with the CPUs. It's not that the parallel processing cannot be done by a CPU. It's not that the tensor computation cannot be done by a GPU. It is stating that it is efficient at doing this particular. So it can also perform a parallelism, right? So that is why it is showing, but it is low. And in comparison for the GPU, it's high, and for the TPU, it's extreme. So whenever you have a large videos in order to process, you usually use the TPUs. So the programming models are C, C++. So right now you might have seen some AI applications which can mimic you, okay, after these many years, how will you look like, right? So can you imagine the number of the computations that is being done for this particular thing? So that is why it may be running good if the particular process is working for a GPU and or for a TPU. Then the programming models are C, C++, Java, Python, and for GPU, it's CUDA, OpenCL, and Direct Compute. For TPU, it's the TensorFlow. The execution model is usually sequential for CPU, massively parallel for GPU, and matrix multiplication optimized execution model for the TPU. Then further, I'll demonstrate the Google Colab. Yeah, before that demonstration, I would just like to point out to some of the references that I usually refer to. So I refer to the Google Colab official documentation. Then I refer to a very good paper from an ACM computing survey that was just accepted in 2025. And I refer to the basic definition of the artificial intelligence and data-centric AI. I refer to again from the paper. And data science, a comprehensive overview, again, an ACM computing survey paper. Then query processing on heterogeneous CPU/GPU system. Those who would like to learn and know more about the heterogeneous GPU CPU systems, or just standalone GPU, standalone CPU, and integrated CPU GPU systems can learn from this particular paper. Then a survey of 3 types of the processing unit has been picked up from this particular conference paper, and exploring the GPU architecture. So the figures that I've shown you for differentiating between the CPU and the GPU is being picked up from this VMware white paper. So now I'll show you the demonstration. Yeah. Okay. So it says that there's one thing, if you see this particular thing, right, you can see here runtime. So after clicking on to this particular option of runtime, there is one thing called as a change runtime. Okay. So this change runtime is that, for example, currently I selected V28 TPU and I saved it. So the corresponding this particular processor will be run at the back end, and it will show me, okay, in how much particular task it completed the task for the demonstration of applying a logistic regression onto that particular red wine data set. Now, if I want to change, right, so it says that changing the runtime attributes will terminate my current session. So it will ask me whether you want to terminate the session because you are already running all the programs. So it means that I need to rerun starting from the scratch, right? So disconnect and delete runtime, right? So yes, I said, okay, I'm okay with it. So what I want is, I want that, okay, you should do it this particular way. So now it started connecting to the Python 3 Google Compute Engine, right? So now what I have to do is, from the point number 1, I have to rerun the program, right? So I have to rerun the program. I have to again upload the files because I have changed the environment. So now I am running it onto a CPU. So now I have to upload the data again, right? So this was the code for the uploading the data. So I had to rerun the code. It prompted me which particular data set. I did it, right? And it uploaded it. So after this, I need to again rerun the program, where what I did, I assigned a binary classification as a good quality parameter, right? And from the quality, I converted that into good quality, and then I will run this particular code. So on running this particular code, the CPU will be used, right? And then the CPU will, that the task is being completed in this particular second, and the time taken to run the particular thing is this very particular number of times. Okay, now I again change the runtime. Okay, then I can select T4. So I again selected T4. I saved it. It will again restart the session. That particular session will be terminated, and it is, if you say, connected to Python 3 Google Compute Engine backend GPU. Now I am running the same program onto a GPU and then correspondingly penning down the time. So first I'll run the program, I'll import the files again. I'll have to choose the files, red wine quality data set. So these are uploading, right? Uploaded, 0 is being calculated. Now since it's an interpreter, I rerun the code. Now if you see, it shows that the corresponding task is being completed into these many number of seconds. Okay. So this is just to give a demonstration that I can change the runtime environment. And then if you see this runtime, you can see that these particular things are disabled, right? A100 GPU, L4 GPU, V8, V5, E1 TPU, right? If in case I want to purchase at the additional compute units, there is an option, I can change this one, right? And I can purchase and I can move on to other ones. And okay, I'll show you simply one difference table. Yeah. So if the GPU type is this one, so it has these many number of the CUDA cores. If it's Tesla T4, it has 7.5. It's an NVIDIA L4. It has 8.6 CUDA cores. The performance is fast. It has a balanced speed, and it is best for big data sets and complex data sets. Similarly, if I compare for the TPUs, there are different 2 TPUs that are being shown over there. So one is having only 1 core and another one is having 8 cores. So the performance here is fast, and here it is optimized for advanced workloads. So it's available for free tier and pro users. It has a limited availability. Actually, usually for pro or pro plus users can use this particular thing, right? So one thing, yeah. So what we did is we considered 3 particular data sets, and considering these particular 3 data sets, where one was of the size 100 KB, one was of the size 2 MB, and another one of the size 50 MB. We tried to do it for the same data set with the CPU, GPU, and TPU, and the corresponding times are being shown over here. So you can see that the CPU involved this much time, this much, and then in comparison to 50 MB, the data time was being increasing. And similarly for the GPU, it was behaving like this one, and for the TPU, it was. So it was just for a simple demonstration that we did it. We divided the data sets and we tried to show it for the different Kaggle one. So now with this one, I would like to stop sharing my screen and I'm open to the questions and answers. Yes, you can please ask your questions. Correspondingly, I'll be able to answer them. I can see there are two particular participants, those who have raised their hands. Or you can write it into the chat box.
Yeah, chat box is not enabled actually. Am I audible?
Okay. Yeah, you are audible. So
Yeah, ma'am, my question is that we have seen a lot of coding in this Google Colab. So is
Mhm.
there any standard format from where we can get this code or we need to write it?
Yes. Okay, I'll simply share my screen. I'll show you.
Dear participants, you can ask your questions one by one. You can unmute yourself.
I'm not able to share my screen again.
Hello.
Hello.
Ma'am,
Yeah,
you
ma'am.
can share your screen. Let's try again.
Okay.
Hello.
Yeah, now it's okay. Okay, let me answer to the first one.
Yeah.
I'll come on to your question as well.
Hello.
Just a minute, I'll take your question and let me answer to the first one. Okay, if you see from this particular place, right, the first thing is welcome to the Google Colab. So this welcome to the Google Colab, it shows you the various demonstration. What is the Colab? It simply tells you getting started. Here it simply tells you, okay, where you can start learning the code. For example, seconds in a day, 24 into 16 to 60, and those are being displayed as an answer to this particular thing. Now it gives you a simple program, how to write a program for a data science. So for the data science, this is the thing. So the front page of the Google Colab, welcome to Google Colab, will tell you all these particular things, right? And here there are the hyperlinks as well, from where you can click onto these hyperlinks and you can further do some further experimentation with that. So Google Colab is a very good kind of a thing, and the homepage itself gives you a demonstration of the particular things to learn, and you can learn all of this coding from the homepage itself. Okay. Yes. Next one.
Hello.
Yes, next. Yes.
Yeah, ma'am. You showed the architecture of the GPU. Like we have different type of the caches are there, L1 cache and L2 cache. So is it
Right.
possible that we can use those particular caches with the help of programming like machine learning and
No. That was, I said, I repeated it again and again, that it basically varies from one particular architecture to another architecture. Okay. So the corresponding diagram that I picked up from the VMware was showing that, for example, the processor cluster was using L1 cache, right? So that's an inbuilt architecture, but with the Google Colab, I'm also not sure of whether I can use it, go into the details of the hardware architecture, and whether I will be able to operate with this one. So as far as the Google Colab is concerned, I can just change the runtime from that particular place, and I can just perform it either on CPU, GPU, or this one.
Thank you, ma'am. Okay, thank you, ma'am.
Yeah, okay.
Good evening, ma'am.
Good evening.
Ma'am, I had this one query that any idea regarding the compute units that one can consume on this Google Colab?
Yeah, that is already being represented onto the homepage. I said that these runtime environments are free, and then this many number of compute units it usually gives as a free. Otherwise, you have to buy.
Ma'am, any other platform which supports this kind of coding or something like that except Colab?
For what particular application or area would you like to use that for?
Say for multi-level image classification.
Okay, so you can use Amazon EC2 as well.
On that, can the even we upload the data set also externally?
Yes, you can upload the data set as well.
Is that free
Right?
to use,
Here
ma'am,
also
or
it's
is that
possible.
also a paid service?
Some units are free and for some you have to buy. So here, yeah, a very good question. I would just like to, I was doing an experimentation with one of my scholars. So yeah, I would like to acknowledge all my master students, all my colleagues and all my PhD scholars as well, with whom I did certain experiments, and those students and those scholars really helped me in preparing these tutorials and these demonstrations. So I would like to acknowledge all of them, and I would like to appreciate them. So what the question you asked is, I remember from one of my PhD scholar while I was working on, and there were very strong review comments. So we tried it on Google Colab, but then our experimentation was onto a MongoDB, and we failed on providing a connectivity of Colab with the MongoDB. So what we did moved on to Amazon EC2. We need to purchase some of the units onto, because our data set was it was a TPCH benchmark data set. So that TPCH benchmark data set was very high, and it was persisted onto a Mongo. So we were not able to find out a method by this particular Colab, but yes, with the Amazon EC2 cloud, we were able to have a connectivity with the MongoDB, which is a NoSQL database, and we were able to compute after paying for some certain extra units for GPU's performance.
Thanks for this response, ma'am. Actually, I am also a PhD scholar, and right now I'm working on a medical image dataset, which happens to be very large. So, would you suggest for me to buy these compute units in Google Colab, or should I go to that Amazon platform?
So what you do is since you do not have any persistence with the database, so I guess your data set is you can save your data set. Yeah, one thing I forgot to mention, that it's not that every time I have to run and do it. What you can do is you once save it onto a drive, and the Google Colab has a connection with the drive, right? So once
Yeah,
you
I
save
have already done that, ma'am.
onto
But
the drive,
a time and
so
again, while running the code, those runtime
yes.
variables that are generated,
Yes. Yes,
just
you
because
can
of
only pen
them,
down the time. Yes. Again
yeah,
and
yeah.
again. Yeah, this is one of the disadvantage that was having. So what we did, we went to one of our HPC high performance computing lab. We used the GPU for that particular lab, and then we didn't use the cloud as a service. We performed the experiment even onto that GPU as well. So what you do as of right, what I would like to suggest is since it gives some amount of compute units free for the TPU, you just try to process it for the TPU and just pen down all the readings with the current one. And if in case your lab has an existing GPU capability, you can further use your lab services.
Sure, ma'am. Thank you so much, ma'am.
Yeah. Okay, sir. Thank you so much for giving me this particular opportunity. I hope I'm able to answer the queries as well. So I would like to have a permission to leave.
A very good evening to everyone present. On behalf of entire Atal FDP team, I extend my heartfelt gratitude to our esteemed speaker, Dr. Shelly Sachdeva, for delivering such an insightful and enriching session on using Google Colab for AI application. Your expertise and clear explanation have truly illuminated the practical aspect of leveraging GoColab for AI solution, inspiring us with its potential to revolutionize learning, research, and development. The session provided valuable hands on insights that will undoubtedly empower participants to explore innovative application in artificial intelligence. We are deeply thankful to your time, effort, and knowledge shared with us today. And we look forward to implementing the idea and technique learned. Thank you once again for your invaluable contribution to success of this FDP. We look forward to future interaction and the opportunity to learn from you again, ma'am. Thank you, ma'am.
Thank you so much. Thank you. Thank you to the
Thank you,
coordinators. Thank you.
Shelly, ma'am. Thank you, ma'am.
Thank you so
Thank
much,
you. It was
Dr.
really a
Anbu.
wonderful session, ma'am. Thank you.
Thank you. Thank you so
Thank you,
much.
ma'am.
Thank you, ma'am.
Okay, ma'am. Bye. Bye.